Today, let's go over a medium question in the monotonic stack section that I just solved by myself. Previously, I could not solve this question and I had to revert to the solution, but today I was able to leverage another problem that was similar and map it onto this one. So I'm really happy that I came up with my own solution. So let's go over it. So you're given an integer array heights, and what you want to do is include an integer array of indices where for the current number, if every number to the right is smaller than the current number, include the index. So 0 here, 2 here, because 3 is the only number. 1's the only number to the right of 3 that's smaller than 3 because it's the only number. And then the last one is always n because there are no numbers to the right. So I solved the smaller numbers except self question. There's a hard question that I solved earlier today. This one's really similar. So let's create a sorted list. And then now of nums, right? So we're just sorting this first. So 1, 2, 3, 4. And then we want to iterate over heights. And the idea is that at each turn you remove whatever we have. So we're only looking at the right. So cur.remove heights of I. This is in log of n time instead of O of n because this is a sorted list and that's the magic of it. So let's print current to see. Sorry, not nums, heights. Okay, so 1, 2, 3, 1, 3, and 1. So that's good. So now let's say we want to bisect left because what we want to do is find inside of current the optimal pivot point for heights of I. So for example, if we have 3, we want to sort it, we want to place it, or let's say we want 5, we're going to place it at the very end. If we want 1, we're going to place it at index 1 because that's the optimal place where no numbers, where it goes in sorted order, basically. So now if we print B, and then let's print I, what should happen if you make some observations is that you should get the length of the heights minus 1 at least as the sum, because that means that whatever we're on now, plus whatever was left, right, two numbers, is all the elements that are to the right of the current element, right? So for example, here's 3 is 0, right? Because there are no elements to the right of it. So this is just going to be 3 is going to be 0. That's always going to go on the list. Always going to go inside of the result at the end, right? So now if b plus I is bigger than or equal to the length of heights minus 1, as we said, right, because 0, 1, 2, 3, think of it as indices, not as the length of 4, then we can print I, and that's a valid answer, right? So if b plus I, not 1, so 0, 2, 3, cool. 0, 1, 2, 3, and 3. So, and now let's create a resulting list, right? So now we can just append I, and then at the end, once we do a linear scan from left to right, we can just return the result. This solves the problem of O of n squared that I came up with before. So, yeah, this is binary search because it's log of n that's better than another O of n. As you can see, it's not the most efficient, but it passes all the test cases. The time complexity is n log of n. So I hope you found this video helpful, and it just highlights the power of the bisect and the sorted list in Python. So please stay tuned for more if you found this video helpful, and consider subscribing. It helps the channel out, and see you in the next video.